Hello, I'll be solving problem 4.18 from the UGURAL textbook today. We have a 3x3 matrix, and we're given that the tensile yield strength of the material is 300 MPa. We're going to solve it first by using the maximum shearing stress theory to find the factor of safety, and then we're going to use the maximum energy of distortion theory. So the first step will be to find the invariance using three equations. The first equation will be I1 is equal to sigma x plus sigma y plus sigma z. So from this equation we have sigma x is 120 MPa, then we have sigma y to be 80, and sigma z is 10. So in total it's going to be 210. Then we're going to find invariant number 2, and the formula for that is sigma x times sigma y plus sigma x times sigma z, and then we have minus tau xy square minus tau yz square and minus tau xz square. And from the 3x3 matrix we can find them. So sigma x is 120, sigma y is 80, sigma x is again 120 times sigma z, which is 10, minus tau xy is 50, which we get from here, square, minus tau yz, which is 20 square, and minus tau xz, which is 30 square. We get that to be equal to 7,800. Next, we're going to calculate invariant 3. Invariant 3 can be calculated by finding the determinant of our 3x3 matrix. Determinant of this 3x3 matrix. And just from a calculator we can get the determinant to equal 11,000. Next, we're going to have to find the principal stresses, and we can do this by using the stress cubic equation. So from the stress cubic equation is Alright, so we're going to plug in our variance into the equation. So we're going to have sigma cubed minus 2,000 minus 210 sigma square plus plus 7,800 sigma, should have been positive, minus 11,000 equals 0. And solving this equation, we can get the principal stresses, which are principal stress 1 is 162.38 MPa. Second principal stress is 46.15 MPa. And the third principal stress is 1.467 MPa. So now we're going to solve part A, which asks for the maximum stress the factor of safety using the maximum shearing stress theory. And we know that the equation will be over n, which is the factor of safety, equals absolute value principal stress 1 and minus 3, and we use these because these will give us the maximum shear stress, and this is given in the question, which is 300 MPa. So we can rearrange the equation and get the factor of safety is equal to the tensile yield strength over principal stress 1 minus principal stress 3. which is equal to 300 over 162.38 minus 1.467, which are these. And we can get safety factor of 1.86. So this was part A, using the maximum shearing stress theory. We get our factor of safety to be 1.86. So for part B, asks us to find the factor of safety using the maximum energy of distortion theory. We can simply use the equation. So principal stress 1 minus principal stress 2 squared plus principal stress 1 minus principal stress 3 squared plus principal stress 2 minus squared. We can rearrange it to find factor of safety. Okay. So we have everything here. We have the tensile strength, which is given at 300 MPa. We have our principal stresses, which we solved in the beginning. And we can just plug and get the answer. So we have factor of safety squared is 2 times 300 squared over 162.38 minus 46.15 squared plus 162.38 minus 1.467 squared plus 46.15 minus 1.467 squared. So n squared will equal 4.35, and then our factor of safety will equal 2.09. So this question used some of the stuff we learned from the first midterm and combines it with the theories we learned after the second midterm. Thanks.